Hi everyone, my name is Sander from team 16441 Pretty Smart Robotics, and today I'm teaching you the basics of object-oriented programming. Object-oriented programming is a feature that some programming languages have and is mainly used for three different purposes. To make your code more readable, to reuse the same lines of code, and to publish your project and let others use it as a library. In this video, I will talk about the two most common features used in object-oriented programming, and those are methods and subclasses. If you have some programming experience, especially in Java, you're probably already familiar with methods. There are two different types of methods, void and non-void methods. Non-void methods are actually just data types. However, instead of just giving it a value, for example, like a double KP equals a certain decimal number, you can actually write some code in it to calculate a different value. So I have a double get target heading, and we'll have some input, make a calculation, and then return that heading back again. So that's also a very interesting feature of the method, is that you can have input variables. So you can use the same lines of code, put different inputs in it, and then get a different return. So for example, I've used get target heading in my autonomous drive program. It will calculate a heading according with the current heading, and that's also calculated. And then it will just define it here. I'm using a heading multiple times in this code, but I'm also using it in get target heading. So the current heading is being calculated every single time, and then with like math.py divided by 2, this heading will be the input for my method, and this heading is probably different every time I call it, so I will also get a different value in return. So those are non-void methods. Void methods are very similar. For example, my public void field centric. Void is standing for that it doesn't have to return anything. With any other non-void method, like if you have an integer or a string, you always have to return something, and it's like a value. Void methods are a little bit different, where you can just put a lot of code in it and it's just executing that code and that's it. You still have the feature of being able to put inputs in here. In this case, I have a speed variable, so I can call my field-centric method, which has all the code in it to let my robot drive field-centric, which makes programming extremely fast and way more readable. So I can just put a value in it, but I can call field-centric multiple times. For example, for field-centric, I don't need to use it 3 times like this, but I can use it in different things. But I can change the speed value every time. So my output will eventually be different because my robot will be driving slower or faster. So that's the power of methods. It's very useful to use in a lot of different circumstances. Any task that you have, which is like a chunk of code, you can put it into a method to make it more organized, and there are probably a lot of tasks or calculations you have to do multiple times. For example, the stop function or the get current heading function, they will be called multiple times, and that's why it's smart to have them in here so you don't have to reuse everything. However, it gets even more powerful because you might have noticed, but this is actually not an op mode class. This is a subclass. There's no run up mode or anything I'm like running here, but I can go to the example tally op. This is just a standard linear op mode, and I can import that subclass into here. So to do this, I need to make the class an object that I can then use. So I have to use the name of the class, and then I have to give it a name. I'd like to use drive, and then equals new mecanum drivetrain, and then this. I will explain this in a second. So with this line of code, I've imported the mechanism drivetrain class into my teleop. And then when I type drive and then dot, I get all the methods that I've created in here. So for example, this is like before the start is the init phase. So I have a specific method with all of my initializations, like defining my motors, setting different directions, etc., etc. Then I can do drive.init, and this will run this specific class, making it initialize everything I want to. And then on the while op mode is active, I can put, for example, drive.fieldcentric with given speed. This is actually all the code I need in my teleop to be able to drive my robot field-centric. And that's the power of object-oriented programming, because it's very organized. You don't need a lot of code. It's a very fast way to program, because there are a lot of functions that you will reuse every year, or make slightly different changes and use it in various different places. So it's very powerful to have a like kind of library of methods and subclasses that you can then import and work very fast with. The other powerful thing is that I don't have to restrict myself to one class to import. I can also go to, for example, an autonomous or an extra teleop or anything you'd like, and then import it again. And again, drive.init, because that's just a standard function that I've made. And then on the while op mode is active, I can again use drive.fieldcentric, although I don't know how useful this is in an autonomous program. But I also have, for example, a method called rotate to heading. And then I can give it a specific heading, like 270, with a speed, like half the motor speed. And I can also like use this one multiple times with different headings. So like 180 degrees I want to go to, and then maybe I want to go to 45, and it will execute this code every single time with different inputs. So now I'm going to show you how you actually need to implement it. It's very simple. Most of it is already what we've done here. Like the mechanism drive is new mechanism drivetrain. So make it an object, and then you can call the methods like I've done here. Your subclass needs to know which op mode it is using, and that's why you have to make a new variable called linear op mode and then my op mode. And then use the statement public and then your class name. So in my case, mechanism drive, and then linear op mode, because I'm using a linear op mode, and then op mode. This part of the code is actually what you're using right here. And that this is because Java knows with some things what it has to fill in. I can also put some code in it that will give the linear op mode, but stating this is a very fast way. Java will recognize it because I've declared it as a linear op mode, and this program only has one which it can use, so it will just use the value in here. Then I have a small line of code, and that is that my op mode, which I've declared over here, equals the op mode given by the program, like teleop or the autonomous. Then on everything like op mode related, so things like calling the motors, because these functions are not in standard Java, but are actually imported from the teleop library or the autonomous library. You need to put my op mode for every one of those things. So for example, the hardware maps, the gamepads, and a couple more like telemetry and such. But that's actually it. You just need to keep these things in mind for your subclass, and then just the way I've imported it right here. It's also the way you import some of your libraries by making it an object. So the methods that are public, you can call them in different classes. There's a difference between public and private, you maybe know this, but it's simply public methods, variables and such will be able to be shown in other classes, and private ones are not. This is just because you don't want to use it in other classes or don't want other people to use it in other classes, or because it just isn't necessary. For example, I don't need to use the get target heading outside of this class, so I just make it private, because if I keep everything public, it will be very messy in here because there are already a couple of methods, but if there are also a lot that I don't actually have to use in here, and it gets very unorganized. But yeah, that's basically it. It's very simple, yet very powerful. I hope you can digest this information and implement it in your own program, so you can reap the benefits of object-oriented programming. But yeah, I hope you learned something, and I thank you for watching.